All right, so welcome to today's video. Today, what we are going to do is we are going to start writing the test cases for the smart contract which we wrote in the previous video. And if you're not following, I would highly recommend you to watch my previous video. We have built a MemeCoin Launchpad and we have wrote smart contract in the previous video. Today, we are going to write the test cases using Hardhat. And previously we wrote it inside remix editor. Today we are going to copy all those smart contracts into our VS code extension, sorry, not extension, but in our file, and we'll write the test cases accordingly. So without wasting any time, let's jump right into it. So open up your browser, and as what I'm going to do is I'll write down hard hat, and yep, let's go to the documentation, and in this you can start here. Let's install Hardhat in our VS code. Create a folder and just install Hardhat into it, and wait for a few seconds. So the Hardhat has been installed, and in order to initialize the Hardhat, what we have to do is we have to write npx Hardhat init. Let's copy this code and paste it right here, and you'll be asked these questions as suggested. We are going to create a TypeScript project, right? And this will be the root. And do you want git ignore? Yes. And install the project's dependencies. Let's do it. And it will again take some time. We are done. So let's move forward. We have these things, and in order for it to run, we have to use npx hardhat. But let's go to the folder structure of the things that we have currently. We have a contracts folder, and we have a pre-built Solidity smart contract. We have to delete it and paste our own Solidity, but everything has been given, all the configurations has been given according to this smart contract. For example, we have log.sol, we'll be having the test for log.sol also, and we'll be having the all the node modules and the ignition for the, in order for it to get implemented, we have the modules for log.ts. We'll change all this when we are going to deploy our smart contract, but today we are going to write the test cases. Let's go to um, let's go to remix editor first to get all the code which we wrote in the previous video, and here we are. So previously we wrote two smart contracts. First was the factory and the second was the token. We have to paste both of them directly into, oh, we cannot copy directly. Let's create a new file. First delete this and then create a new file named factory.sol. Let's paste all the files here, like all the contents of the file here, right? And let's create another file named token.sol, right? And paste all the content of token into this. And I think it won't cause any issues now. All right. But we haven't installed OpenZeppelin, right? Let's go to npm openzeppelin docs, right? And here we are. We have to install this openzeppelin/contracts. Let's just copy this, paste it, and enter. All right, it's done. So let's open up again, and we are not being shown any errors now. So we can start our workings now. We have to write the test cases for the token and the factory. Basically factory, because the token has been or is being managed in the factory.sol only. So let's go to test and delete this, or just rename it what factory.ts, right? And just delete everything. Let's start from the beginning. So let's open up this factory.sol on the side also. I hope it is visible. um, Let me do one thing. Yep, I think it's visible now. So let's start the smart contract. First, what we have to do is we have to deploy the smart contract, right? So we have to write the test for the deployment also. How we're going to do that? Let's do a simple it block. For example, in a it block, what we have to do is, what it does is, I'll show you. All right, before doing it, let's describe a block in a deployment, right? And it will contain a function, um, right? In this function, it will be having an it block, and it should deploy. It should deploy the contract, and this will contain an async function, right? And let's see how we can deploy it. Mhm. Yep. Before moving forward, I would like to tell you that how we are going to deploy it. So whenever we are going to deploy, we have to pass two values. For example, here we have a fee and the owner, right? So in order for us to know whether it has been deployed, we have to check whether we have set the fees and we have set the owner or not. So instead of directly going to it should deploy the contract, well, what we are going to do is we are going to check whether we have deployed the fees. For example, it should set the fees, right? And it will have an async function which will contain factory contract. So let's create a contract right now. How we are going to create a contract in the test, I'll show you right now. um all right, so let's create a factory. Oh wait, we are going to use ethers, right? Dot get, we haven't, I don't know why it's not auto importing. Const ethers equals require ethers, not, sorry, hard hat, right? and you're going to expect also use, so const expect equals require, um it will be from Mocha and Chai. Yeah. So we are going to use both of them. First, we are using ethers. So let's see how we are going to use ethers in order to deploy the contract. Get contract factory. This is a function that we are using inside. And what will be the contracts factory? It will be named factory, right? Now, this was a kind of instance factory, sorry, factory equals await factory dot deploy. And when we are going to deploy, we are going to pass a fee, right? So let's pass a fee. Let's create a function or a const fee variable which will be passed as fee. Ethers dot you are going to parse units, right? And we are going to give 0.01 in the 18th decimal places. So I think I have described how we use this in this code or something. If not, I'll tell you right now. What happens is whenever we describe any uh, value in the web3, what we are going to do is we describe it in about two decimal places. For example, we are describing 1 ETH, we'll do it as 1.00 in general, not in web3. But when we talk about web3, we don't only give two decimal places, we give up to 18 decimal places. How? Like we have two up until now, we'll do 18 up to 18 decimal places, like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. This value will be passed directly, and we don't give decimal points when we pass values in Solidity. I don't know why no developer, like most of the um, developers and the tutorial videos, they don't talk about this. Very few videos they talk about this, but we don't pass this decimal, right? So instead we just pass the numbers after which decimal point should be included. And we have point zero 0.01. So and so it will be defined as like this, 1000 something like this. This will be 18 zeros, and after 18 points we'll place a decimal. How we are going to do this? After, like, it's total of suppose how much, let's see, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Okay, we have added more. So it will be simply like one suppose it's total of 18 value or 16 values, let's say. What we are going to do is we'll add some more zeros in front, right? So the total units will be 18, and after that we are going to pass a point, so it implies this value in reality. This, sorry, I hope you I'm clear with the what the concept I'm trying to teach. The example was not very strong, but what I'm trying to convey, I hope you understand. So we have deployed the factory, and in order to deploy we are passing a fee, and we are, sorry, we, I guess, oh no, all right. And this fee will be passed here only, right? Now the deployment is done, and we have to set the fees and the values. So what we are going to do, let us expect we are going to expect what, like, factory, this smart contract should have the fees, right, to be equal e- no sorry equal to fee. I guess that's await, sorry, we have to do the await. This is only for the fees. We haven't added the message.sender, right? We'll do it in a minute. Let's try to check if it is working or not. npx hardhat test. Um, let's see. Yep, we have. This is passing. So again, if we want to check the if we want to check if the like the message.sender has been set or not, what we are going to do, we are going to create again. It should set the owner, right? For this we'll have an async function, right? In this again we are going to deploy the smart contract in order to get the value, right? And then what we are going to do is we are going to be expecting that the factory this sorry, this is not what. All right, the factory dot owner, which is this guy, right, to be equal to the like the deployer, right? But we haven't set the deployer. We have to set the deployer also. How can we get the deployer value? Mm, we are going to use again ethers library. And how we are going to do that, let's see. So how we are going to do is we are going to use ether library like this. Deployer will get this value from the ethers.get signer, right? Signers. And when we call this now, we get an array of values, and these are the list of addresses which are not in real, I mean they are not used in the real world basically. And the first value will be the deployer or the signer of the smart contract which we are going to deploy in the testing. So when we call out a specified name, we are expecting the first value of the arrays which we want from the get signers, right? Get signer has multiple values. The first array with the index 0 will be called out as deployer. We are setting the name as deployer, and this will be used to be equal to deployer dot address, right? Let's try to run this hard hat test. Let's see. Okay, it is not a function. No problem. Sorry, this is not a function then. Let's run it like this. Yep, it's passing. So when we are deploying, we have the owner and we have the fees also. If you want, I mean, if you want, you can directly console log it here also. And the deployer.address. Let's console log it here only. Deployer, right? And the owner. Let's compare them side by side. Factory.owner. You'll see that there's a difference, right? In the factory.owner will be having different value as compared to, I'll show you. Right? You won't say that they're exactly equal because it's a promise, right? We have, it's basically it's still getting executed, that's why. So all right, let me check it once like this. Yep, now we are having equal values, like both or the values are same. So the deployer and the owner are same, and that's what we were expecting. So we got the correct values right now. But Before moving forward, I would like to tell you one thing, that we cannot do this every time. You see, we are deploying the smart contracts every time when we want to use the factory. So in order to avoid this multiple running of the same function, what we do is we create before each block. And what before each block does is it, before running all the describe function, it runs a before each block, which will be having all the parent values which will be used in these child functions, kind of thing. You can think of it like that. And instead of using before each, which we used to use previously, now we are going to use a fixture function. Now what's fixture function? I'll show you. It's a simple function only, but instead what we do is we wrap the function which we want to call inside the fixture. I'll show you. The functionality is same as before each, which I described right now, right? So let's instead of writing and calling out this function every time when we need it, let's wait. Let's create a fixture kind of thing that will be having a factory. So how we are going to do it? We are going to describe a factory, right? And it will be having a function, sorry, function. In this, we'll describe this first thing, right? We don't have to explain it every time when we are going to use it. And now what we are going to do is we are going to deploy the factory function async. It will be async function deploy con factory, right? And let's name it deploy factory contract. It looks good. I mean, makes more sense. Now what we are going to do is we are going to get the deployer here only, like this one first. Let's get the deployer first, right? Makes sense. Now what we have to do is we have to deploy the factory, this values. Let's paste it directly here, right? After deploying the factory, what we have to do is we have to return the values like deployer and the factory, right? Let's first return them and use it directly. Return deployer and factory. Sorry, factory. Let's use it here. How we are going to use it? That's the main question. Let's first delete this. And now what we are going to do is we are going to call out. Just a minute. Yep. Const. We need deploy factory, right? Factory, not this. Factory from who? From this. What is this function? Deploy. Why am I writing everything? Deploy, and we have to pass it inside the fixture load, right? I mean, actually it's just calling it, right? Not exactly calling it, just pointing it. Load fixture. It's not getting imported. Let's call it then. I mean, it's from Hardhat actually. Import const load fixture equals require. I mean, you can use import, just use it in directly from, you can change it the import module from here only. Yeah, that's how you have to do. You have to basically change it into type equals module and you can do it. I'm not that much interested into changing it. I'm more interested in the working of it. So that's what it is, right? Yeah. All right. So deploy the contract. Load fixture has been called out and we are not getting the name. And how is that possible? Await and fees. Just a minute. All right. Okay, sorry. We have to call it inside this only. I mean, cannot just call it randomly outside the described block of factory. Then only it will work. This is the parent. Consider this function as the parent because it will be used in every functions. So now it's all good. Let's call the, let's move these values also. Directly we can use it since, right? And we need deployer also. Lawyer. That's what we're passing it. Now let's try to run the test case and expect the same result as before. Hard hat test. Yep, we are getting it. So cool, all good. So what we have to do is, now what we have to do, let's see. Now we have to get token sale. We have to create a token. um the thing is, let's create a token first, right? We created the factory here. Let's, we deployed the factory here. Let's create a token first. Const token. So I'll show you how we are creating a token. First, in order to create a token, we have to create a transaction, right? Await factory, this only. And we are going to connect it to the person. Just a minute. Let's keep it here only because we are going to need it. We have owner and creator, right? Similar to that of the factory, we had only owner here. We have owner and creator. So we have to pass creator here in the connect function, right? Because that is what we are getting in the constructor when the constructor function runs. So in order to get the creator, we can get, we like, whichever address is being passed here is being created as the creator, right? So we can take an address just for the testing and pass it as a creator value. And how we are going to get any random address? We are going to get it from get signers only. It has multiple values. So if we just take the second value, this was the 0th index, right? Let's take the first index. How we are going to take? Let's name it creator. And we got the first value with the index, well, I mean second value with the index of 1. This creator will be passed here, creator. And we have got the creator, and let's create. This is how we are going to create. We have to pass the name, the symbol, and the value, total supply. And how we are going to do that? We have to pass name, our code, name of the token, symbol. mm, let's give symbol as RCD, right? And the total supply will be passed like this, value, right? And the value will be equal to the, I mean, apologies for the background noise. This value, fees, will be the value. We have created a token, right? And in order for it to get executed, we have to wait. So we are calling out wait transaction, token transaction dot wait, in order for it to get executed. Now you might ask, we are already using await function, await, why do we need to wait? I mean, the reason is because when we execute this transaction, we are getting a uh, you mean a transaction receipt in return. And if it is successful, we have to move forward. If not, then we have to show it has been failed. If we won't wait, we'll get the value, and regardless of if it got created or not, we'll still move forward instead of showing the error message. We have to avoid that. That's why we are using transaction.wait. We don't have to go that deep. We can understand this is how transactions are being used. Now let's get the token address which has been created right now. How we are going to do? Const token address equals factory dot token, tokens, multiple tokens at 0, right? We have to wait for this. And yeah, all right. And for this token address, what we are going to do is we are going to get the contract. For example, this is the token. This was the token address. Now we get the actual token. Await ethers dot get contract at the token, the token which we have, this one, and we are going to pass the address of the token. Address. We got the token with the smart contract of this, right? Now this token will be passed everywhere. Cool. Makes sense. Now what we have to do is we have to create a token. Now we have to check, basically, when we create a token, whether we are able to set the name and the values or not properly, similar to what we did for the factory. When we deployed, we checked whether we are passing the fee and the owner or not. Similarly, for token, we are checking whether the owner, creator, and the total supply has been minted or not. How we are going to do that? Let's create a function for it. All right, let's create a function describe block. Let's create a describe block of create token, sorry, token, and it will have a function. I mean, you can use a normal function also, and it will have, when we are creating a token, will have an owner, a creator, and a total supply, right? Owner, creator, and total supply. So we have three blocks: owner, creator, and total supply. When we did factory, we had two because we did for fee and owner only, this and this. For token, we have three, so we'll create three blocks. Let's create for owner first, right? Let's, it has should set the owner, right? And it will have an async function. Cool. Now we are going to set the owner, and we have a factory, always this one only. All right, this same line. We have a factory and a token also, both. Now what we are going to do is we are expecting that token dot owner to be equal to the creator dot owner, sorry, owner dot, just a minute, we have to compare the token, token's owner, which is this, should be equal to the smart contract which created it. This place, who created this smart contract? I mean, who created the token contract? The factory contract, right? We have a create function here. So this factory contract's address should be equal to the owner. So we are going to have owner as factory dot, sorry, get address. This is the function. Right, let me check this. We have to wait for the address, get the address. Let me check this once. Npx hard hat test. Yeah, it's passing, so it's all good. Cool. This is the correct one. This was for owner. The same will be for creator. Let's understand. Should set the creator, right? Who will be the creator? Token dot owner, not owner, but creator. Creator should be equal to the uh, creator dot address. We yeah, this creator. We have passed it. No, we haven't passed it. We have to pass it also. Tokens creator should be equal to the creator which we used in the first one, this one. So we are getting creator and await creator dot address. Creator dot address. You might ask, we are using this address here simply and we are getting get address in the factory because this is the factory contract and we have get address function for it. Creator is the variable here, that's why we are using direct address for it. Not a and a kind of object which has this. So let us, we don't need this. Let me run it once again. um, no one is failing. Creator dot address is not a function. Okay, sorry. Yeah, as I said, it's an object that has this um, property. Let's try it again. Yeah, now we are getting it. Cool. We are getting now creator's address, and last left is total supply, right? Total supply will be equal to the, I'll show you how we are going to use it. Okay, inside this only, it should set the supply. Sorry, it is an async function. And now what we are going to do is we'll get token and same this one. We got this, and now we are going to get the uh, total supply. Let's create a value which it should be equal to ethers, for example. When we create this, right? All right, so when we are creating a token, right, we are passing these many ethers. So let's check if it is equal to these many ethers. How are we going to check? Ethers dot parse units, 6 zeros, right? So 6 zeros, let's pass 6 zeros here also. In And as I said, we have to pass the decimal points also, 18 decimal points. The total supply, we are expecting that the um, tokens total supply tokens total supply um, no, it has not been set previously. What we are doing is we are minting it, so we cannot use total supply. There is no function right that. So we have to check the balance of the token, right? So the balance of await factory dot the address actually. because this all right, yeah, we are getting the like we are getting the balance of the token with the address of the factory, and this we are expecting that this is equal to the total supply, right? Yeah, I think I'm getting there. We don't need this. Let's run this for once and check if it's okay. Yeah, we are correct. So this is what we were expecting. The total supply which we passed here, this is getting minted. So that's what we were checking. It is correct. So the creator block is also I guess no, we have to do more. We have to set the supply, right? We have to set the ETH balance and create the sale. Okay, we have got three left in my notes. Okay, yeah, it makes sense actually. Yeah, we have to. It's not just that. We set the creator, we set the supply, we have to set the ETH balance now. How we are going to do that? Let's do it. It should set or not set, update the ETH balance, and again we have async function. All right, I'm ready now. We want the factory like this only, and what we want the balance. Let's set the balance, get the balance basically from the ethers. We want to get the balance of the factory. How are we going to get that? We're going to get through providers, ethers dot provider dot get balance from what? Factory address. Get address. We want to update the ETH balance, right? That's why we are getting the balance first, and we are expecting it to be equal to the fee here, right? So expect what? Balance to be equal to the fee. This one, right? Make sense? Should update the balance. Yeah, that's what we are expecting. Now we have to create the tokens which can be bought by the investors. It means we have to create the token for sale. So let's create token for sale, async function, and now const, again like this only. I mean, we don't need this here. Let's move this, and yep, we got factory. We need token also because we are, and when we are creating token for sale in this function, create, we are passing name symbol, right? Okay, let's see how we can do. We have factory token, factory and token. So let's we had previously the count also. I mean, I realized why do we need to use the total tokens also actually, we cannot just directly use the length of the array which we have. I mean, we can use, but it will be better if we have a separate variable for the total tokens. That's why it's good to have total tokens number instead of directly using the array. If you don't understand, you might have not watched the previous video. I was referring to the add length of the array, like the array length is equal to total tokens, so why do we need it? But I realized next time that we need it because it will be better while testing. So now we are creating const the total count equals await factory this total tokens, this variable. um, we are expecting that total count to be equals how much initial. I mean, we haven't created initially anything, so we are expecting it to be zero, right? Because we are testing it right now. Now, sorry, we we don't have to pass it here as yeah, this as this and equals, we are expecting it. No, sorry, I guess I apologize. This is how we have created. So we have one token currently, right? So we have to pass one equals to be one. The number is equal to one. We have one token because we have created it here only in the fixture, right? Yeah. After that, we have created for sale now. Yeah. So say sale const sale. This one basically token to sale equals await factory dot token get token sale. Sorry, get token sale. This function. This function. We are. I've created this one more function. When I was learning, I realized we need this for testing, and it's simple. We pass the index and return the token. We get returned the token to sale. For example, if we pass zero value, we will get the details of token to sale which we created. This one, this token's value will be returned. And what will it contain? It will contain this token sale values like token name, creator, address, sold, raised, and whether it is open for sale or not. So when I pass zero for now, I'll show you. Get token sale, right? And in this we are passing zero to get the zeroth index token, which is this one, the current created in the testing. We'll get the sale token, and the sale token contains many things. For example, the name which we created right now, the symbol, the total value which is fee. We'll check all of this in the it block. So not in, I mean in the it of create token for sale. How we're going to check? We are expecting that sale this dot token, which is this one, to be equal to await token dot um, this token dot address, right? Like the token address should be equal to the token to sale currently, because we have already created it in this testing. And we are expecting the creator. We have to get the creator also, right? We are getting creator from the factory contract. Expecting creator sale dot creator creator. Let's just copy this to equal to the creator, this one, creator dot a- address, and this is not a function. We have sold, expect sale dot sold to be equal. I mean, equal and equals both work, so whichever you choose. Currently, initially, when we initialize any token, like we initialize this, we have initial value as 0 for both this sold and raised, so both should be equal to 0, right? Sold dot raised, and again we are, whether we it is open or not, whenever we create, it is initially equal to true. So is open equal to true. This is what we are expecting. All of these values should work in order for it to check whether the created token for sale is live for working or not. So let's dry run and check if it is working or not. Hardhat test. Yeah, create token for sale is perfectly working. Cool. This was for sale, right? um yeah, get token sale. Now let's create for buying, like we have it for create token describe. Let's create for buying describe, because buying and selling both will be different. uh, Buy token, right? And we'll be having a function, and in this what we are going to do is we'll be having um, we'll set the values first. I'll show you two values we need. Let's write it down, and then when I'll use it, then I'll explain, right? First we need a cost equals weight, obviously ethers dot parse units. What for? I mean, one value up to 18 decimal places. And what's the problem with an async function? Okay, we haven't given an it block, but I mean, okay. And the next variable will be amount await ethers dot, again, parse units, and the value will be 1,000, 10,000, 18. Makes sense. Now let's use it in the some of the it blocks. These values will be used in multiple it blocks. That's why we have created it in the root of the describe, right? First it block will have in the buying token will be that, well, while buying we should check whether the uh, token, basically the balance of the token or the total tokens, is equal to the total amount or not. How we're going to check that, I'll show you. We have to basically just a minute. Actually what we have to do is we have to update, like we have this buy function, right? And first all these where is it? Yeah, in this buy function, first all these constraint. After that what we are doing is we have to check that the total amount of the balance of the token is equal to the fee plus the total cost of it or not. Initially we are adding one for the cost of individual token and the amount of tokens which we have minted equal to 10,000, right? And why is that? We have already shown you, just a minute, sorry, we have already shown you here that we are calling out total amount of token to be this much ethers. All right, let me write this function first, then I'll explain. um it's a bit confusing. Okay, we have to update the ETH balance, right? Async function. In this, what we do is we get the factory again, right? Now what we have to do is we have to mm, mm, we have to check the balance first, because await ethers dot provider dot get balance, um, get balance of the factory, get balance, and this is a function. Whether this balance is equal to the fee and cost. Okay, we can do one thing. um okay, so what we are going to do is we are going to expect the balance to be equal to the fee, I mean, where it is, this fee plus the cost of individual, right? The balance should be equal to the fee and the cost of the token which is present here, right? So that should be equal to the balance of the factory. That's what we are going to check, right? This is what we are expecting while updating the ETH balance. Now, after that, what we have to do, we have to move forward. We have to add another it block. Let's complete the describe of it block, then only we can check the testing of it. So we have should in update the token sale price, right? Not price, but the token sale async function of hmm, const, again same, right? I mean, we are not using any of it here, so that's cool. Now what we are going to do is we are going to create a sale, sorry, sale for similar to what we did in the previous describe block. What was token to sale and token to sale we are passing um okay, yeah, token to sale we are passing the address to get the value of that particular token, right? Token dot this tokens dot address, get address. Make sense? Now this sale, I mean the first token which we created, it should have some values like the amount, total amount, the cost of the token, and whether it is open or not. That we have to check whether it is open or not. So we should expect sale dot sold to be equal to, I mean, this amount. Okay, and sold, and then we have to check whether it is raised, because we are checking the token sales update value. We are not updating the token name and creator, right? These values are the values which needs to be updated. Raised is equal to the cost of the token, right? This is amount we have raised one already, and whether it is open or not. So currently it is not equal to the, I mean, the constraint which we added, that both, it is if the sale dot sold and raise is not less than target and the token limit, we are still um, true. So if we have to set it to true, we have to check whether it is true or not, and technically it should be. That's what it was. And after that we have to, yeah, okay, um token sale, we have to increase the base cost also. Yeah, we have to increase the base cost also. So how we are going to do that? We have to should increase the base cost on async function, right? We have to check whether the base cost is ready or not. So first we have to get same thing, I mean, see, that's why we have created the fixture. We are needing it everywhere. So base cost, I mean, first let's get the sale for it. I mean, same thing for the, we're getting the token details directly, token to sale, the first token which was created. This has become monotonous, to be honest. Token dot get address, right? We got the token. Now we have to give the cost, get the cost, await this, get the token to sale contains it, if you remember this, right? The cost. So factory, sorry, the the cost of, yeah, okay, we don't have to get the uh, token cost, but the factory cost actually here, because we are increasing the base cost, right? Should increase the base cost. So first we get the cost of the factory, get cost. I'll show you this function, uh, because this function is being used in while buying the token, if you remember. Like, I'll show you here, this is here, and it is being used here while buying the token. We got the cost of because we passed the total number of tokens, and this, I hope you remember the way we do this, right? We have the floor, and for every increment, I mean, from 0 to 9,000 values, the value remains and the floor only. And for one single increment, the total value increases, and it stays there for 10,000 to 19,000, the way we explained. If you don't remember, I would request you to go to watch the previous video. It was pretty good explanation in that video. So we got this function, factory.getCost, and what we are going to pass, the total amount sold. this one. I'll show you how. Sale this, where it is, this sale, suppose we created first initial sale dot sold. This is what we gave initially. Sale dot sold is 0, so that's what we are going to check. I'll show you. So the base cost gets increases, right? So it won't be 0 actually. Let's check first. Expect cost to be equal to the third dot. Let's expect initial cost to be let me check once. How many errors? 3 errors. Should update the ETH balance, should update the token sale, and should. Okay, 3 is failing. Get balance is not a function, and expected should update the token sale. Okay, and base cost expected this to is equal 0. Expected. Okay. All right. Let me try it. Get address is not a function. Let me fix this once and check if it is working or not. Alright, so still 3 is failing. Means that is not the only issue. Alright. Actually, we were comparing it through this only. This was wrong actually. I misunderstood this. I apologize. What we have to do is we have to create one more fixture actually. I'm checking it with the actual code currently, and I realized now this is not we have to what we have to do. Most of it is ready, correct. Last 3 is wrong. The it block inside the this buy token, this section is wrong. Not completely, just one minor thing that needs to be done. Let's do it right now. I'll compare it with my actual code and then we'll move forward. Just a minute. Yeah. So when we are buying now, we have to buy the token multiple times, right? If you see, we are buying token in the buy function, and then depositing also we have to buy token, then only we can deposit. And while withdrawing, we first need like the token bought, then only it can be deposited, right? So basically in every section we have to first buy token. So buy token can get monotonous. What we have to do, we have to create a fixture for buy also. Let's do it right now. We have a factory, we have deploy factory contract. Just below it, let's type an async function of deploy buy token, sorry, buy token contract, right? And in this, what we are going to do is we are going to call out the factory, this the above code only, factory, similar to this factory deployer, everything will be called here. Factory deployer, not deployer, creator, buyer, and token. Now why we are doing, because token bot needs to be used everywhere. While selling the token, you need to have some token to sell, so it means you have to buy it first. So this is the base one. Const amount equals ethers dot parse units. And instead of, now I understand why we were using it. It's not direct random value that I thought that we have to compare it through this. No, we don't. I was wrong there. I corrected it with my actual code while I wrote in while preparing this. So I hope it will get clear now. Okay. So amount which we were using previously will be equal to the 10,000 total, right? And it will be up to 18 decimal places. Now the cost of individual tokens will be ethos dot parse units and 118. I hope I'm clear. Now what we have to do is we have to buy some tokens. How are we going to buy in the test? Like this, similar. uh, where is it? Token transaction, this one. Makes sense. And then we will pass it directly, return uh, all the values which are being passed from here, so as to make it I mean a fixture. You might ask, I mean, you could have done this above also. Why did you do it here? I mean, because when we are deploying a contract, we have to only pass we have to create a smart contract, I mean the token, and pass it individual values, right? The token in initial tokens, and it should have all the initial values. When we are buying a buying a token, we need to set the amount and the cost also individually, which we are doing it here. Just a minute, we haven't changed it. We have to pass the cost for testing, right? And previously we were not passing the amount. We will pass amount also here. Now it makes sense. We will be having amount, and these values will be changed actually. Initially only for one token we could have used, but now we cannot, right? Wait, we are buying actually this function, token address, token dot get address, right? And then we have amount which we have passed, and we have cost also which we are passing, which will be checked as this one, message dot sender, message dot value, sorry. That is being passed as cost. Initially we are passing this value. Now it should buy token, should work. Where are we? We have inside this load fixture. All right, so now I think it is working, and let me check it once. Npx test. Yeah, it is working right now. So I'll tell you what issue was. Initially we set the eth buy amount for cost and total amount, and what we did was we created a token contract in which we will call out this deploy factory contract, and will call out all these values. One more thing, we are calling another address. If you don't see, I called out another address from get signers, a random smart uh, wallet address, and it could be referred to as a buyer. Suppose he wants to buy something, I mean buy the token, and we called out third person, third wallet, and passed it directly from to the return value, and we are getting it to the buy token contract, the buyer, and this address or the wallet will basically, this address will buy the token. How we are going to buy? This is the code for buy tokens, which is, first we called out the transaction. First we connected to the buyer and called out dot buy function. And we, when calling out buy function, we are passing token address and token amount. We we passed get address and the total amount. And for message dot sender, we are passing the cost value which we declared here only, right? We are calling out one. We are, the cost we are passing is one. uh, we can call it, and the total amount is the 10,000 values. And yeah, that's that's what we are doing it here. This is the total amount which we want, and let's use this buy token contract as fixture in buy token describe everywhere, like this everywhere. I've used this buy token contract because in every place, like when we want to update the ETH balance, we have to buy a token. When we want to update the token balance, we should have tokens, so we have to buy tokens. When we have to update the token sale, we have to buy the token and increase base cost then also. So in all those values, we used buy token contract as a fixture. Fixture is before each, which I explained previously. So I hope I am clear right now for this. I guess I haven't explained these two. So I'll explain you these two. Should update the token sale. It means we are updating the token sale. How we are going to do that? We called out buy token. It means we bought some token first, and we have factory and token values for it. This, and then we called out the sale, which was this for individual sale. The token with the address, we called out that, so that we can get individual the value sale which is at the address of token. And we are expecting that the sold value to be equal to the amount which has been passed. The raised value should be equal to the cost, right? The raised, initially it was 0, but here while buying, we are, by default, we are telling it the amount and cost. And while using the describe method, we are passing it the same value, so as to compare and match, make sure that both of them are same. And yeah, where it is, buy token. So we expected the sold token to be equal to the amount which has been declared in the root of this describe block, the cost to be equal, and currently both of them haven't passed the threshold, so currently it is open, so we expect it to be open. Now we are increasing the base cost. How we're going to do that? First, we described the factory and the token. We called out buy token contract. Now we are calling out the sale again just to get the first token which we bought with which was present at get address, and the cost for that factory. I mean that token. The cost, if you see, we have defined it here only. No, we haven't. All right. So get cost will be the function which has been used here. This step increment function which we are using. The sale dot sold is being passed, and what we are expecting it to be that the cost should be equal to 0.0002, and when we run it, it will work perfectly fine as we checked it right now. I hope it's clear. So apologize for the previous one, the issue which we were causing, like we were still we were passing the deployment only instead of token. I thought that is the only thing. I misunderstood it. I apologize. So moving forward, what we are going to do is we are going to call another block which will be for deposit, right? Let's do it for depositing. describe block for deposit, right? And it will be a function. um, yeah, inside this function we will again um, const same values, amount equals ethers dot parse units to be equal to 10. First we are calling out 10,000, 10,000, yeah, and 18 decimal places, and the cost will be equal to ethers dot parse units again to be 2 and 18. Cool. When we deposit any token, right, uh, we have to check whether the token has been successfully deposited and it has been like the token which is open, it should be closed. So how we are going to check it? We are going to create a it block sale should be closed and deposits should be successful. I mean, it's quite long, but you can create a shorter sentence if you want, according to your needs, right? In this, we will again same thing, because in order to deposit we need to have some token, so we'll buy some token. These values are similar to the values defined above. Just for comparison, we'll check whether the value present and the value defined in the root are equal or not. So these many tokens, yeah, okay. Factory token, we need more things, creator and the buyer also. I hope I'm clear right now. And let's um, when will the in order for the tokens is open to be closed, we need to make it at least greater than or equal to the token limit, or the target should be equal to the total raised value, right? So what we can do is we can buy some token in order for it to reach the token limit, right? So let's buy more token, await factory dot connect from the buyer, this one, I think I have passed it previously. Yeah, this is the buyer, right? And from this we are going to buy the token, this token, pass the address of the token which we are going to buy, and see, we are using this function buy. Let's check what values do we need to pass. Token address and the token amount. How many token amount? um I mean, let's like, we just need to check whether the amount, uh, just a minute, yeah, we just need to surpass the token limit or the target, right? Let's buy all the tokens, sorry, all the tokens, right? So let's do that. How many tokens amount we are buying? All, which has been defined here, so that it will reach the limit and value will be equal to the cost. Make sense? And we await for buy tx dot wait. Let's wait for the transaction to get completed. And now sale will do is factory dot token to sale. Await token dot get address. Now we'll check this sale is equal to be false. Why? Because we have bought all the tokens. The threshold has been reached. So this should be equal to false. That's what we have to check. Let's check it. Expect sale dot is open to be equal false, because we have reached the threshold, right? And sale is closed now, and we have to make the deposit successful also. In this, you could create a separate it block for deposit also, but let's do it here only. So const deposit transaction equals await factory dot connect by creator, right? We're connecting the, what we are going to do is we're going to deposit some of the tokens, and in order to deposit the tokens we need to get the creator, this guy, because the creator can only deposit, right? See, the token has been transferred to the creator, gets transferred to the creator, not the buyer. So we need the creator so that we can deposit the tokens into the creator's account. So how we are going to do that? Deposit the token dot get address. Right, let's wait for deposit transaction to get sorry dot wait wait for the transaction to get completed, and after that we'll get the balance and we'll check, I mean, how much we are deducting 2 units from this many values, right? So not this many, but actually, just a minute, initially how much it was. Yeah, if we, okay, total supply, let me check it for now. Okay, it is passing for now, so let's see. Deposit is successful. So when it gets deposited, it means the total amount will be deducted. I mean, the total 10,000 should have got deducted from the balance. Let me check. Const balance is token dot balance of creator dot address, right? Yeah, and what we are expecting is the balance if we are calling all the values, like if we are reducing all the values, I mean, someone, the buyer bought some the 2 unit tokens, right? Cost and amount, so that much should be deducted. I mean, it should be 98000, right? I I hope I'm correct. To equal ethers dot parse units, since from 10,009 this much should left, I think, and it should be up to 18 decimal places. Why? Because from 10,000, not this one actually. Let me check once. Mm, mm, all right, I'll confirm it with my original code also. No. Okay. Yeah, it is correct, but we're getting two uh, decimal places. Oh, okay, okay. Sorry. Um, yeah, it needs to be two digits more, right? Makes sense. Makes sense. Cool. Yeah, that's what it is. So when we did deducted 2 units from the actual values which we had, what we are going to get is the buyer bought some of the tokens, so the total amount of token left in the contract will be equal to 2 unit less than the total token present given into the smart contract. So what the total token left in the smart contract, if the creator now expects it to get deposited into his account, that much token only will be deposited into his account, not the amount which was bought by the buyer. Like the buyer has the right now for that, not the creator will only get the tokens which are left in the smart contract. I hope I'm clear for this now. Yeah, okay, makes sense. What is withdraw? Okay, withdraw, let's write it for withdraw, and withdraw will be comparatively simpler. This was a bit hectic actually. I had to compare it multiple times with my original code where I have learned from fees function. Um, it should update the balance. That's all it is, right? Yeah. And while we're drawing, we are just passing the um, message.sender the amount which has been passed to the owner, and we are checking whether it is successful or not. Let's do that. We just need to check the ETH balance then, and async, right, will get all the value from the okay, yeah, we'll get all the value from factory and deployer, which will get from the fixture, main fixture, wait, load fixture, and deploy the factory contract, that one, right? Const, sorry, tx equals the transaction await factory dot connect the deployer, right? We called the deployer. Now we'll call this function withdraw, not the capital but the small. And what will be the amount? The amount is actually the fees here. That is the withdraw which we want to withdraw, right? Now let's wait for the transaction, and when it gets completed we'll get the balance of it. Const balance equals wait ethers dot provider dot get balance and factory dot get address. this balance will be expected to be equal to 0 because all the values has been withdrawn. How much is left in the factory? 0. So what we are expecting now, balance to be equal to 0. Okay, let's run. Okay, it's passing. So I hope you guys understood what I wanted to explain. In fact, I'm also learning new things while writing these things, and if I get stuck somewhere, like which I did today, I compared my code with the original code from which I learned, and I found some issues, and I explained it and corrected it. I hope you understood the part which we were facing some trouble in. Apart from that, I think everything is clear, and this was it for today. And I would like to say that testing is quite important while understanding and writing the smart contract. And apart from that, yeah, that's it. That's the thing that we had to do today. Next, what we are going to do is we are going to deploy the smart contract into Hardhat test network, and we'll create a front end around it so that we can access it directly. And after that, yeah, we can test our front end, integrate it, run it locally, and we'll make sure everything works fine. So I hope you liked the video and found it informative. If you do, make sure to like and subscribe, and follow for more. Thank you.